Welcome back. Today we're taking a look at this transistor tester. I actually got this in a recent mailbag video and I decided to do a full review of it with a teardown at the end, so stay tuned for that. And I got this particular device off of eBay. It was less than $23 and it's a transistor tester as it says, but also tests other things, as you can see by the little data plate on here. And I got this just for testing different components out in the lab here. Especially things that I've taken off of another device, or in the case of the capacitor ESR, as it says down at the bottom there, that's the resistor, capacitor resistance I should say. And that's important to know because as certain resistors get older, the resistance goes up in them and that throws off your circuits. So if you're looking for issues, you can use this to test the components out. And it's also good for identifying some kind of rogue components that you don't really know what they are. And the premise of this is you just insert whatever component is between these pins here, and these are all wired, by the way, in parallel the way down here. So this is all pin 1, this is all pin 2. And pin 1 here and pin 1 here is the same as well. So as you're connecting things, just be wary of that. But if we take something like this capacitor here, and if we look and see, this is a 3300 microfarad 16 volt capacitor, and if we just insert this in here like this, and I'll move this down here a little bit and hit the test button, which is the bottom one here, you get the transformer logo, and then it self-tests the battery, and it does take a couple seconds to get the result. And you can see it's a capacitor and it's coming up as 3373 microfarads, and it has an ESR of 0.08 ohms. And it also shows you a little diagram and what pins the connections are. So 1 and 3 obviously, because this is big enough where it's just bridging over pin 2. And it shows you the V loss. I'm assuming that's the voltage loss. It's 2.6%. And you know, you may or may not need that information, but after a while it times out I should say, and then you can power it back up again. And I haven't seen this yet, but there's a indicator up here of a low battery, and I'm not sure if that'll blink or turn solid or not, but you can see that up there. And we're just testing the same thing out, and you can see there is slight variances between results, as can be expected. Same thing with the ESR that went up, and we didn't do anything at all with this. Now it tests this by sending pulses out. In fact, if I use an LED here, I'll show you what I mean by the pulses. As this comes up, you can see there it goes. And it's actually just sending a signal in both directions through all the pins, and so it can try to figure out what it is. And by that I determined it is a diode with a forward current of 19 nanoamps. And of course it goes, you know, a lot higher than that. It is an LED after all, but that's probably the very minimal that it caused to trigger it. And this is most likely the forward voltage. It looks like a U, but it's probably just because they couldn't. Oh, no, they could put a V. I'm not sure why it says U, but that showed the forward voltage. This actually came with a little adapter here. I'll just zoom out. I'm not sure off the top of my head what these are called. I'll put it up here on the screen somewhere. But this just has a bunch of pins that insert back into the bottom there, and then you can use this little kind of gate thing going on here. So you'd actually just insert whatever device you want to test into the gates and lock it down, and you get the idea. Works pretty well, and that's good for using chips and stuff like that. But you know, there's certain things this won't test. In fact, you can see when you don't get any connections, there's no unknown or damaged. So that's a clear indicator there that either there's something wrong, which you just kind of check it, you know, make sure you got the connection right, or maybe it is a device that just can't check. Now here's an instance that it's pretty handy for. Here's one of these little potentiometers. So this is an adjustable resistor. If we zoom in up on it, it says 103, so that's a 1 and 0 followed by 3 zeros, so that's 10,000 ohms, so it's a 10k resistor basically. And if we put this in here, you can see that a couple of the pins will line up. So there's pin 1 and pin 3, and then the one down here is going to be pin 2. And then when we turn this on, This is going to show us the resistance, basically of, hopefully it'll show us, there you go, all three of them. If you don't get contact, it's going to show you just one resistor, because after all, this is 3 resistors. You're just adjusting the quantity of both resistors with this knob. So this is, like I said, it's a 10K. So if we add those 2 numbers up, we get pretty close to it. And if I just adjust this anywhere I want, now they're not going to change live, but if I turn this knob in any direction and I retest it, we will see that those numbers will, of course, change. Now, the difference between a tester like this that tests many components and other testers which test just singular components is, well, a few things. First, we'll show a LED tester. This thing here is just basically going to show you if an LED works or not. And there are different resistors to put out different current levels, so you can actually insert this and see what the minimum you'll need is. And it goes from 2 milliamps all the way up to 150 milliamps. And if you insert it the wrong way, it just won't light up. So, you know, it's kind of like an idiot test, I guess you could say. But we could put that in there and see, and it's instant, but that's all it's going to do. It's just a 9-volt battery and some resistors. So while it is specialized for testing LEDs, it doesn't really give you any kind of data, unlike this. The other tester, of course, is a multimeter. Now, if you look, my multimeter can tell you ohms, and that's it. So I can't tell capacitance from this. Some of you can. The difference is with the ohms, it's constantly polling, so it's always sampling with the leads here, unlike this one. So, you know, and you can do other things like check voltages, obviously, but you know, this is a specialized unit. It does only certain things. It would be nice if you had some of the functionality in this built into here. Like, for example, if you tweak this knob, the values changed on the screen. That would be kind of nice, like it would do here. But that's, you know, an argument for another time. You know, they are different things. This is a multimeter. This thing is a component tester. Now, these come in a variety of different shapes and sizes and whatnot. You can get it in kit form where you can build it yourself, I've even seen. Some of them have little leads that come off of it. They do frequency tests. They do things like that. I haven't seen if there's any special menus in this or not. Sometimes if you hold down a couple of buttons at the same time, it does something or whatnot. It goes into a programming mode. This one, I have not got it to do anything at all like that. Now, I mentioned the teardown. Oh, and I should say, some of these don't even come in cases. So I picked this particular one up because of the case, but to get to the teardown part, you can see we have this little transformer logo here again, and this is covering up one of the screws. So that's definitely some kind of a tamper-proof device, if you will. But you know what? I don't really care. For the price of it, if I foul it up, I foul it up. So, and that's actually a pretty good screw. I might just jam the screwdriver right in there. Let's go ahead and disassemble this. Alrighty, there's the 9-volt and the 4 screws out, and of course the little sticker punctured. And let's see what we got inside here. Ah, that's kind of cool. They put the logo on the board. Yeah, it's pretty simple as was to expected. You can see there's really not a whole lot to it. There is a website on here. Perhaps we'll check that out and see if that does anything interesting. And it just has a little spot for marking the date it was put together, although it's not marked. And there's, as I say, bugger all in here. There's really nothing. Although, there's some spots for some components up in the top there, which is pretty interesting. I think we may have to take this apart a little further here and see what we got. I got all the screws out and just started giving this thing a brief look over. And some of this is done by hand. Some of this is done by machine. And that's kind of evident if you look at all the SMD stuff on here in the middle of the board. It actually looks really great. Everything's on there just right, but then you start to look at some of these pieces up here. Like this definitely looks like that was hand soldered. You can tell by the flux as I kind of move the light around here. And also there's definitely a lot of components missing up here. A microchip of some sort. If you anywhere it says like R, these are all resistors, obviously. C's are capacitors. And you can see there's quite a few things missing, but this little like U4 here, U2, those are little microprocessor chips of some sort. DC, this is maybe an input. Up here you can actually see there's 3 leads. I'm assuming this is for an LED, and there's the hole for the LED to mount on the other side, but there is obviously no LED, so that's pretty interesting. Not sure what all this is going to do. I'd be interested in if I could find a schematic of this, or maybe purchase one of the ones that's loose. Now, from what I could tell down here, because it seems like this is where power comes in, this is possibly a 5-volt regulator, and obviously the main controller circuit here. And that seems like that's a Atmel chip. I can see it from the angle I'm looking at it. You probably can't pick it up on camera too well, but that is the Atmel logo there. And if I just take a quick look at it, yeah, that is an ATmega 328P chip. So that's basically an Arduino, and we do have a crystal over here to set the speed on that. And yeah, if you look down here, these pins are all hand soldered too, and you can see where the traces go up to, I'm assuming these are like sense resistors. And there's another connector here and here. Now maybe that's a JTAG connection, so you can reprogram this, not sure. And yeah, you can see this is also meant to be kind of used without the actual case here. This screen just sits into place, and the leads that go up to here that say LED on the back, on top here, that's for the backlighting. And then they just like hot glued the screen in place. Nothing fancy. This is definitely what I'll say a textbook component tester, because these things are pretty commonplace nowadays. And at this point, this board, I would say, is probably not Creative Commons. It may be just one of those things that so many people copy. It's just widely out there, but it's not intended to be one of those things. I'm not really sure. You know, with the way with these Chinese devices, it could be somebody else's device that they just completely blatantly ripped off. But at any rate, there's nothing really more to see in here. If you want to check out that website, check that website out. I'm not sure what's on there. If you wanted maybe reverse engineer what that might possibly be doing, then do so now. But if not, I'm going to go ahead and put this back together, and we're going to run a couple more components through it again. Okay, and you can see everything's back together now. And I forgot to mention when I had this apart, most of the component values are actually marked right next to the component. For example, when I noticed where the crystal oscillator was, there was 2 capacitors next to it, and those were of course 22 picofarad capacitors that you'd normally have next to a crystal like that. And the whole board was marked, with the exception of where there were the components at the top that were unmarked, that just had, you know, resistor and the number for the resistor. So I'd be pretty curious to see what's up there. But here's a couple more components. You can see here's a little inductor. Now this particular one, I have a feeling something's wrong with it, because it actually comes up as having a it's like a 0 ohm resistor. So that may be just either a fluke with the tester, or I just had it connected wrong before when I first tested it. Yeah, see, it's coming up as a resistor. Whereas if I use another inductor here, this guy here, this one does actually come up with a value, which is pretty interesting. So it's not the most accurate thing. And I'm sure these things exist in a little bit more of an accurate format, but it does kind of do the trick. And based upon, you know, considering that's more or less an Arduino, and it has to have a database of all these parts, or at least try to guess what the part is, it does a pretty good job at it. I mean, it's not perfect, but what do you expect? And well, I don't really have anything else to test. Maybe I can throw a diode in here just to show what that does, but it's going to be pretty much the same as what it did when we showed the LED. And that's pretty much it. Now what's nice too is this diagram depends on what pins are actually hooked into, and it will change. So if I change the orientation on this little diagram will flip and show you the other, you know, the other way, obviously, which is nice, because if you're just getting into this, you can see the diode diagram has a little bar with a triangle pointing to it. Well, that little triangle, that little bar, happens to be the little white line that's on the diode right here. So it's basically pointing to that. So if you need to orient these things based upon a schematic or something, you can kind of use this, I guess, to cheat a little bit and show you which way it's pointing. You know, hey, sometimes you you know the answer, but you just kind of forgot it from not being too keen on this stuff, or maybe you're just getting back into it, or maybe you're just learning it. So this would possibly be a good use of a tool for that. Well, with that, I don't really have much to say more about this, so I'm going to say thanks for watching this video. If you're not already a subscriber, you can click up here in the corner to subscribe. You can also check out these two videos over here if you want to see some more of my stuff. Don't forget to give a thumbs up or a thumbs down, and to share this with your friends. Thanks for watching. We'll see you next video.